And is it recording? Okay, good. All right, let's start all over again, okay? In fact, I'm going to approach it a little bit differently. So, objective. The law of sines. 4, 15, 21, okay? So I'm going to approach it differently because I was thinking about something else. I'm off today because I'm thinking about track. Okay, so the law of sines, what we're going to do is solve non-right triangles. So let's draw a triangle. You guys already have one drawn. But it's not a right triangle. So I'm going to say theta. I'm going to go theta 1. And it's opposite side because there's no hypotenuse. Theta 1, opposite 1. Here's my angle. There's the opposite side, okay? Now we need a second angle. Theta 2. And then its opposite side. So we'll call this opposite 2, okay? So the law of sines, before I go any further, you always must have, a pair of opposites. Okay, you must have a pair of opposites. Guys, write that down. You must have a pair of opposites. So take a look at my first example, which I haven't given you the formula yet. But here and here, I have a pair of opposites. Do you see that? I've got an angle, and there's opposite side. I have to have, to use the law of sines, you absolutely have to have a pair of opposites. Angle, opposite side. Okay, so I've got my pair of opposites. How does the formula work? Well, it is going to be opposite 1 over sine of theta 1 equals opposite 2 over the sine of theta 2. That is the formula. Super easy, isn't it? That's just this little formula here that will actually solve for non-right triangles, okay? So let's take a look at example 1. Let's see if we can use this, okay? So first of all, everything starts with opposites. I have angle B, which is 54, and I have its opposite side, okay? That's big key. You guys see that, right? I have angle C. I know angle C, so I should be able to find its opposite. So this becomes opposite 2. Does that make sense? I've got theta 1, opposite 1, theta 2, I got my second angle, and its opposite side. So what I'm going to do is find its opposite side. So I'm going to find AB. So using the formula, I'm going to set up then opposite 1, so I'll go 12, right? Opposite 1, 12, over the sine of 54. Okay? The formula says opposite 1, that's the 12, that's side, over the sine of its angle, okay? Equals opposite 2. We don't know what opposite 2 is. That's our unknown. That's AB. Or you can call it X, or you can call it little c, but I'll call it AB. Opposite 2 over the sine of its angle, over the sine of 83. Okay? So it's opposite over the sine of its angle equals opposite side of the sine of its angle. Okay? Opposite side of the sine of its angle equals the opposite side of the sine of its angle. Okay? Now, I'm just going to solve. To solve, I'll just multiply, I'll multiply the sine of 83 up. Let's multiply it up. I'll have then 12 times the sine of 83 divided by the sine of 54 is AB. And just use your calculator to get the answer. Okay, I'm going to go ahead, clear. We're just going to go 12 times the sine of 83 divided by the sine of 54. And I get an answer of 14.7. Does that answer make sense? Looking at the triangle, does a 14.7 make sense? Yeah, I mean, if this is 12, that could be a 14.7. Okay, so 14.7. What do you think? Thumbs up? It's pretty easy, isn't it? Okay. Now, the law of sines can also solve angles. You can see that, right? So when I want to find an angle, the only difference I do is I like to write the formula upside down. I like to put the angles on top. You don't have to. It's just easier to solve. So let me rewrite my formula. Okay, sine of theta 1 over opposite 1 equals sine of theta 2 over opposite 2. It just makes it easier to solve if your unknown is on top. Does that make sense? If your unknown is on the top of the fraction, it just makes it easier to solve, okay? All right, so here we go. What do we know? Well, do I have a pair of opposites? Okay, must have a pair of opposites. Must have a pair of opposites. I do. I have a pair of opposites. They are angle B and the 7. You guys see my opposites? I've got my angle, and I have my opposite side. I have an angle and its opposite side. So I have a pair of opposites. What I can find, I have this side, so I should be able to find its opposite, right? So it's all about opposites. So I'm going to use this formula. All right, so I'm going to set up sine of theta 1, sine of 48, over its opposite side, which is a 7, equals sine of theta 2. Well, I don't know that, so it's just sine of A. That's what I want to have to find. I don't know that angle, so sine of A over its opposite, which is 4, okay? So sine of an angle over its opposite side equals sine of an angle over its opposite side, okay? So again, I'm going to solve by cross multiply. Bring up the 4. Cross multiply. And I'll rewrite this as a 4 times the sine of 48 over 7 equals sine of A, okay? How am I doing? Okay, and then I'm just going to use my calculator. 4 sine of 48. Close the parentheses. Always close your parentheses. Close your parentheses divided by 7. Okay, now I got a 0.42. That can't be the answer. 0.42 can't be the answer. What am I missing? Yes, Zoe. Thank you. Hallelujah, Zoe. So if you want to find an angle, what button do you have to push? Inverse. The inverse. So I'm going to go second inverse of sine, right? Sine inverse of that answer. And I like the answer button because I don't have to retype it. You guys know where the answer button is on your calculator? Now that answer makes sense. 25.1 degrees makes sense as an angle, okay? So we're going to add something to this in a second. So I know that angle A is equal to my 25.1 because I took the sine inverse of my answer, okay? Now, I'm going to add that. So up here, when you want to find an angle, we're going to have to use my sine inverse button, okay? Thank you, Zoe. Totally right, okay? Now, if this angle's 25.1, and if we have to solve the triangle, so there's still some things we don't know, okay? Well, now we're going to get into a little bit of geometry. So if I take a look at what I have in this triangle, there's one more thing I can find easily. What is that? What can I find easily in this triangle? Yeah, angle C, because there's 180 degrees in a triangle, right? So we're just going to set up our 180. So for angle C, it's going to be 180 minus these two angles, right? 25.1 plus 48. And then that should give me angle C. Thanks, Spencer. 180 minus parentheses 25.1 plus 48, and I get an answer of 106. Oh, I was going to say, is it really that big? I guess it is. 106.9, okay? All right, now, we'll get one more thing. I put my 106 up here. I need that 106 in here. Okay, I got to find this side. You cannot use Pythagoras' theorem. You cannot. You cannot. So to find this other side, What did we learn today?
Use the inverse.
We can use this formula, right? We can use a lot of signs, right?
Oh, yeah.
So, do you have a pair of opposites? It's okay. Do you have a pair of opposites?
Yeah.
You can find a pair of opposites. So let's find AB. Let's call it X right now. Okay, so I've got my opposites, opposite, 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 opposite. So I'm going to use this formula to find the remaining side. So I'm going to go 7 over the sine of 48. Equals side over the sine of its angle equals side equals X or AB over the sine of 106.9. I like your enthusiasm, Dallin.
Thank you.
I do. That was awesome. It shows that you're confident enough to take a chance. I like that. Okay, and then multiply this up, right? We'll multiply that up. We'll have 7 times the sine of 106.9 divided by sine of 48. Under normal circumstances, I would have taught you the law of sines in Algebra 2, but I didn't last year. We just didn't get time. So we're going to learn it for the first time. It's not that hard. You guys agree?
Yeah.
Sine of 106.9. Close the parentheses. Always close your parentheses. Divided by sine of 48. And I get an answer of about 9. Okay, does that answer make sense? Look at the triangle. If this is 7 and that's 4, could that be 9? Sure. Answer makes sense, okay? Are you guys ready to turn the page? Okay, so now, let's see if we can use this. So 2 lighthouses are 45 miles apart. Both spot a disabled ship at sea. The lighthouse on the west spots a ship at an angle of 54 degrees from the shoreline, and the lighthouse from the east spots a ship at 72 degrees from the shore. Okay, so let's just draw a picture. Here's my shore. Okay, here's my boat. Okay, and I got 2 lighthouses, okay? Okay. I know that they're 45 miles apart, right? So I'm going to make this be 45. So the lighthouse on the west, that'd be over here, right? Spots at an angle of 54 degrees from the shore. And the lighthouse from the east, that'd be, this is the east, 72 degrees, okay? And so how far is the ship from each lighthouse, okay? So what I want to find is this distance, let's just call this X, and this distance, we'll call this Y, okay? Now, I don't have a pair of opposites. I need a pair of opposites. I need opposites, right? But I don't have a pair of opposites. But I could get an angle. I could get an angle and have a pair of opposites. Spencer, what did we do on the last problem?
We solved for the third angle.
You guys agree with Spencer? Let's find this angle right here. You get the third angle, and then we'll have our opposites, okay? All right, so I'm going to go angle B, we'll call it angle B for both, okay, is 180 minus the 54 plus 72, right? And let's see what I get. Okay, so 180 minus my 54 plus my 72. And I get an angle of 54 degrees. Is that right? Must be 54, 72. Huh. Okay. 54 degrees is the same as that. Okay. And now I have my opposites, right? Opposite, opposite. So we can find X because 72 and X, right? I've got my opposites. So if you have a pair of opposites, we can set it up. So I'm going to go side, opposite 1, 54 over the sine of its angle equals the side over the sine of its opposite angle. And I'm just going to multiply. Okay. So I'm going to take this and multiply. Oops, I'm sorry. I'm going to take this and multiply it this way. Take this, multiply it up here. So I'll have 54 times the sine of 72 divided by the sine of 54. Yeah.
Wouldn't it be 45, not 54? Isn't the opposite side 45 and the angle is 54?
Oh my gosh, I'm dyslexic. Thanks, Zoe. That's going to change this answer, isn't it? I knew something was wrong, Zoe. I knew it. Oh,
Wait,
yeah.
So the side angle, so it's 50. So the sine 54 degrees is right, but it's 45 on top of the sine in the formula.
Oh my gosh, I'm really having a day. I tell you, thanks, Zoe. So this was, what's this one again?
That's so 54.
That's 54, but I didn't put 54. Where did I make my mistake?
In the formula, you put 54 over sine of 54.
Ah, that's why I got a weird answer. So this sine of
45.
45. Oh my God, you guys killing me.
45 over sine of 54.
Oh my golly. Yeah. Okay. Thanks, you guys. So this should be a 45 sine of 72 divided sine of 54. Is that right, Zoe? Is that right?
There you go.
45 sine of 72 over sine of 54. Wow. Sorry, kids that are going to watch this online. Man.
I was probably watching this with you and say, oh my gosh, I'm dyslexic.
Yep. I know. And they got a 52.9. How's that? I got track of my brain. It's not anybody's fault but my own, but I definitely have track of my brain.
It makes students feel better when they.
Okay. Oh man, I tell you, I had a math teacher in high school who said, "Oh, I don't make mistakes. I did that on purpose. See if you're paying attention." We're like, "Are you kidding me? Seriously?" But he didn't say anything, right? Because he was the math teacher. Like, "Are you kidding, dude? You made a mistake." But anyway, okay. Then to find y, well, the same thing. Okay, well, the same thing. We'll go y over the sine of 54 equals opposites, right? Opposites. So then we'll go 45, right, Zoe? 45 over the sine of 54? Well, y's got to be 45 then. Well, it's an isosceles triangle. It has to be 45. Yes, has to be 45 because isosceles triangle. Okay, that's what I have. Without messing it up too badly. Oh man, makes me almost want to record again for the afternoon and get the recording right. But I won't. Stop.